This is the video for the last part of section 2.2, where we're going to be using a z-score table, which is showing on the screen here, sometimes referred to as table A or the z-score table. There's two sides of this table. The copy you have probably has half of it on one side and half of it on the other side, so that way I could actually print it a little bit bigger so that everybody could read it more easily. Sometimes we'll see it both on the same side, but just know there's two sides. One, on the z-scores are negative, so the z will be to the left of the mean, and the shaded region always to the left of that z-score will be less than 0.5 because it's to the left of the mean, and the shaded region is always to the left. The other side, where they have positive z-scores, these areas, which is in the table here, will always be greater than 1/2 because we are to the right of the mean, and the shaded region to the left will always be more than half of the area under the curve. So for today's lesson, you will need your z-score table. You will also need these notes that were supplied to the sub to hand out to you. So these two sheets are necessary. And then you also have, let's see, I guess the homework will be out of the book. So you don't have a worksheet for the homework. That's right. Okay. So, so you need those. And so let's get started. So z-scores. We've talked about z-scores. Remember, it's a way of indicating where in the distribution you are, or how many standard deviations above or below the mean you are. All normal distributions, like we've seen in the last couple of lessons, will always condense down to the exact same if we translate them in units of standard deviation from the mean. So what we do is we standardize, or we take a normal distribution and we turn it into the standardized normal distribution, or using your z-score thing. So remember too that the normal distribution is denoted with a capital N, and then in parentheses the first, looks like an ordered pair after the N, but it's the mean is the first number and the second number is always the standard deviation. So when we standardize, then this normal curve will have a mean of 0 and a standard deviation of 1. Okay, and so remember that z-score tells us how many standard deviations we are above or below the mean. It'll be positive when it's above, it'll be negative when it is below the mean. All right, so this is a visual of what we're doing. So we have some sort of normal distribution and we standardize it, and instead of looking at how many standard deviations, here the standard deviation seems to be about 2.5. So rather than looking at how many 2.5s we are above or below, instead we just take and convert it to a z-score, which tells us how many standard deviations above and below we are. The table that we use, table A, is all based on a standard normal distribution. I mean, if you think about it, if we didn't standardize, we would have to have a different table for every normal distribution. And as a result, we would have to have millions and millions of tables, because each distribution would be different if the mean is different or if the standard deviation was different. So we have millions and millions of possibilities out there. But if we standardize first, then we can use just one table, the table A, the z-score table. All right, so let's first look. We're not going to use the table for these first examples. So letter A. For all of these that we're going to use on this sheet, we're going to assume that it's a normally distributed distribution, and that the mean is 24 and the standard deviation is 2.5. So for this whole sheet, assume that is true. Okay. So so A. So we want to know if the observed value we're interested in, 27.2, if that is the data we're interested in, what is that data value's z-score? So we'll use our formula for the z-score. We'll do z is equal to, and then our observed value, 27.2 minus the mean divided by the standard deviation. So that gives us a 1.28 z-score. That means that we are 1.28 standard deviations above the mean. That 27.2 is 1.28 1.28 standard deviations above the mean. So we could draw a little picture, and that's what it would look like. There's a vertical line right there at an x value of 27.2. It's to the right of our mean. All right, let's try B. If x is 19.5, what would its z-score be? Again, assuming we're still on the normal distribution with a mean of 24 and a standard deviation of 2.5. So we would use our z-score calculation again, 19.5 minus 24 divided by 2.5. That gives us a z-score of negative 1.8. So that means that 19.5 is 1.8 standard deviations below the mean because it is negative. All right, so a picture would look something like this. Notice we're below the halfway point. Our z-score is negative. Okay, so now we're going to get into using our z-score table, or table A. All right, so the table tells us the shaded region, which corresponds to the percentage of our observations that are above or below a particular value. Well, below in the table, but we can also find above by subtracting from 1. So let's look at C. So what percent of observations are below 20.3? Now again, we're still on that same normal distribution with a mean of 24 and a standard deviation of 2.5. So first what we need to do is figure out what is that 20.3's z-score. So the z-score is 20.3 minus 24 divided by 2.5. That gives us negative 1.28. So let's draw a picture, and I know when you draw your normal curves, they're going to look kind of crappy to start with, but with practice, they will get a little better. So draw a little picture and label where your z is, and where is that 20.3? Something like that, right? To the left of our mean. It's not really important that you get it perfectly to scale, that the shaded region is perfect. I think I used a piece of software to create this normal curve. But, you know, so long as the vertical line that you have is to the left of the mean, we're going to be pretty happy with that. Okay. So that would be our z-score. Now, what we want to do is we want to take our z-score of negative 1.48, and we're going to go to the table, and we're going to find in the table will give us the area to the left, and that's what the table does. So let's see. All right, so now we have a z-score of negative 1.48. So that I find the whole number and the tens place in the left column, and the top row gives me my hundredths place. So together that's negative 1.4 and then 8 at the top. So I sort of like add those numbers together, and that would give me negative 1.48. So I go up and I go down and across, and that is the area that corresponds to a z-score. So the area to the left underneath the standard normal curve of a z-score of a negative 1.48 is about 7%, 0.0694. Okay, that's the little area to the left of our z-score of negative 1.48. So you can leave it as a decimal or a percent. If you said about 7%, that would be fine too. But, you know, it's probably safest not to necessarily round too much. All right, so now let's look at this one. Above 26.7. First, want to find the z-score. And 26.7 minus the 24, and divide that by 2.5. So clearly our z-score is positive here. And draw a picture. The picture just helps you visualize what's going on and which area that we're dealing with. All right, so we want to shade, we're shading to the region to the right. So you have to be careful. The table does not give us areas to the right. It only and always gives us shaded regions to the left. So let's go to our z-score table and look at 1.08. So 1.08 is here and here. And again, I see the intersection of that column and that row. And so that means the area to the left of that z-score is 85.99%, or 0.8599. Right, so that's the area to the left, and we want the area above, which means the area to the right. So we simply have to subtract the number that the table gave us from 1. And that will give us the 14% that's on the right or above that z-score value. So you can see it's important that you draw a picture and do some shading, because invariably a lot of you will just write down something like 86% rather than the 14% that the answer is. Okay, so shading, drawing a picture and shading is very helpful, especially if they're asking for some weird values. All right, D. Now they're going in reverse here. 85% of the observations are above what value? So we have a certain value and we want 85% of the observations to be above that. So let's draw a picture with shading, a normal curve with some shading. And it should look like that, right? We know 85% of the area is to the right. That means I know my vertical line should be to the left of the mean. That's the only way that I would get that shaded region to be 85%. All right. Now we have to be careful. We're not going to go to the table, the body of the table, and look for 0.85, because the table always gives me shaded regions to the left. And so that's the 0.15 is what we're going to look for. So we're going to find our z-score. So we're going to go in reverse now. So now we're looking for 0.15. Sometimes you just won't find 0.15. So you want to find the closest value in the body of the table. And that is right there. And that is not exactly 0.15, but it is the closest value. So we read off, we go left and we go up. Together, those numbers give us our z-score. So we have a z-score of negative 1.04. Now we're going to take that z-score and we're going to use our z-score calculation, our formula, and we're going to work in reverse. We know z, we know the mean, we know sigma, we don't know x, and so we want to work backwards this time. And so we get an x value, a data value of 21.4. Again, we're using the same distribution for all these problems. Mean of 24, standard deviation of 2.5. All right, let's look at E. What percent of observations are above 20.3 and below 30.7? So let's draw a picture with that one. This one's getting complicated. So, we have shading sort of in the middle between two values, above 20.3 and below 30.7. All right, so what does this really look like? If we break this down, it really looks like shading below 30.7, and we want to take away the shading that is below 20.3. Visually, hopefully that helps. All right, so we want to find our z-scores. And the z-score for the 30.7, that's 2.86. We want to find the z-score for the 20.3. Oh, wait a minute, before we go to that, let's go back. Let's find our area for the to the left of that z-score. So we have 2.68. So we're looking at 2.6 and 8 and the intersection of those two. So 0.9963. All right, so that is the area here, 0.9963. And now let's work on the next normal curve. So let's find its z-score. So for the 20.3, that's negative 1.48. So now we go to into the negative side of the z-score, and negative 1.48 is at the top and the intersection. Okay, and so that's the area to the left of the next normal curve. So that's there. Okay, so really when you break it down into its components like this, the problem's really not that hard, but you can see drawing pictures really helps. And so the area we're interested in is 0.9963 minus 0.694, or 92.69%, or if you want to just leave it as a decimal, 0.9269. Okay. All right, F. So now we want to know what percent of observations are above 27 and below 22.9. So now we're shading on the outside. Draw a picture. See if what your picture makes sense. Should look like this. So we want to go the shaded region, the area that's below 22.9 and above 27. All right, so we want to figure out what those z-scores are. So the z-score for the 22.9 is negative 4.4. And so if we go to our z-score table, I'm not showing this part, but go to your z-score table and find the shaded region to the left in the body of the table for a z-score of negative 0.44, and that gives us 0.3300. Okay, now let's look at the other one. Z-score ends up being 1.2. So go to your z-score table and look for 1.22. You will have to subtract that result from the table from 1 to get this value. So the table gives us a 0.8849, but that's to the left of 27, to the left of z-score of 1.2. We have to subtract it from 1 to get the area on the right. So the answer here is we would just add those two values up, 0.3300 plus 0.1151, and that gives us 0.4451 as our answer for F. All right, cool. Let's see, let's go on to the last problem. G, so now back to one where they give us the percentage or the area and we need to find the observed value. So we're going to find the z-score first and then un-z it and find the x value. So what does 17%? So 17% of the observations are below what number? Think about drawing a picture and think about where the vertical line was. So that 17% of the observations are below what number? And so it should be that vertical line is to the left of our mean. So we know that that is 0.17. We need to find the resulting z-score value. All right, so we go to our table, and in this case, again, we're on the negative side because we know our z is to the left of the mean, so it's negative. We look in the body of the table for 0.17. And that's the closest there, 0.1711. And so we just take the closest value, and so that is the z-score of negative 0.95. And then we simply use our z-score formula, working backwards because we now know the z, we're looking for the x. All right, and so the resulting x value would be something like 21.625. All right, so your homework is from our book. It's these problems, and these are due next class.